Welcome everyone, my name is Mr. McGregor, and in this video we're going to be looking at pressure. By the end of this video, you'll be able to define the term pressure and use the pressure equation to calculate pressure and find force and area. So what is up with pressure? Well, in this diagram we have two masses here in the grey, one on this side, one on this side, and they are the same size. So therefore they experience the same gravitational force pulling them down. However, on the left we can see it's sitting on a large block of wood, and on the right it's sitting on a small block of wood. This means that the one with low pressure has not sunk as far as the one with high pressure. You can see here it's sunk a little bit further. And the only thing that is different between these two situations is the area underneath each of those masses. And that area is the key thing about pressure. This is our pressure equation, that pressure is equal to the force divided by the surface area. P is the pressure measured in a special unit called pascals, F is the force, and A is the surface area, which must be in meters squared. Here is our magic triangle. So we're going to look at two examples to start off with. Here we can see some pretty awesome pictures of some people water skiing. The guy on the left is barefoot on one foot, and obviously the slalom skier on the right hand side. So the question is, what is the pressure for each skier? Now I have to make up some numbers. Let's assume they both have a mass of 80 kilograms and that they're both standing upright on their skis. So not quite what the skier in the right hand photo is doing, but that's alright. So therefore, if they're both standing upright, it will just be the gravity force acting, which in both cases would be 800 newtons. Now let's think about the area, and let's start with the skier. The skis are approximately this side, 1.7 meters long, 0.1 meters wide, and let's assume it's the same width right the way along. This means the area, I can get that by simply multiplying the base times the height, gives me 0.175 meters squared. Now I use my pressure equation. Pressure is equal to the force divided by the area, so 800 divided by 0.175 gives me a pressure of 1,100 pascals for the slalom skier. Let's think about this man's foot. Let's assume it's about 28 centimeters long and 8 centimeters wide, and again we'll assume it's actually the same width right the way along. Obviously it's not, but this makes our calculations a lot easier. We note though that that is in centimetres, so in order to calculate the area in metres squared, I need to turn the centimetres into metres before I multiply the two together. Once I've done that, I simply go force divided by the area once again, and we get a significantly larger pressure, 35,700 pascals. Let's look at a different situation. This is obviously the wheels from a 747, and my question is, how much mass can the concrete support, or how heavy can the plane be before the concrete will crack? And the concrete can support approximately 30 megapascals, which means 30 million pascals. If we look at our magic triangle, in order to find the force, we need to know the pressure and the area. So I did some research. This is the approximate sizes of a tyre for an airplane of this size. And let's assume it's 0.7 meters long and 0.4 meters wide, gives me an area of 0.28 meters squared. Using my magic triangle, I know that force is equal to the pressure times the area, so 30 million pascals multiplied by 0.28 meters squared gives me a force of 8,400,000 newtons. But that's not the mass of my plane. To get the mass, I need to go force divided by gravity, so I'm dividing it by 10, gives me 840,000 kilograms. Now that is the amount of mass that one could be, or the concrete underneath one of the tyres could support. And the good thing is that a 747 has a mass of about half that, 440,000 kilograms. So the concrete is definitely going to be strong enough to support this plane, given that it's got 6 wheels here, which obviously reduces the pressure by a factor of 6. So now you know that pressure is equal to the force divided by the area, and you can use the pressure equation to find both pressure, force, and area.